I'll be walking you through the second paper of OCR Physics A, and this is following my first paper of the series of Set 1 papers. And so let's dive right in. So we've got the first question as a student blows across the open end of an empty bottle. Which diagram shows a possible stationary wave pattern for this bottle? So open end will always have a empty node, okay, and an empty bottle will obviously have a closed end, so it will have a node at the other end. So the correct answer, therefore, will be C. Okay, so a node at the end where he's blowing from, so this is empty node, and the closed end of the tube is going to be the node. Okay, so question number 2. Violet light is incident on the surface of a metal. Photoelectrons are emitted from the surface of the metal. The frequency of the radiation incident on this metal is increased, but the intensity is kept constant. Okay, so we know F is equal to the energy of the photons, which is also related to the work function and the maximum kinetic energy, okay, EK max. And the intensity being constant just basically means that the current is going to be constant, okay, so current remains constant too. So which statement is correct? The value of the Planck constant increases. That's not the answer. The work function of the metal increases. No, work function of the metal depends on the metal itself. The number of photoelectrons emitted per second increases. Nope, that's because the current, okay, and the number of photoelectrons emitted per second is the same. Okay, if their intensity is the same, then this is not going to change either. But the maximum kinetic energy of the photoelectrons increases. Yes, it would. So D is the answer. Question number 3. A battery of EMF 6 volts is connected across a resistor of resistance of 12 ohms, and the potential difference across the resistor is 4.5 volts. What is the internal resistance of the battery? So EMF is equal to V plus I times R. So that's equal to 6 equals 4.5 plus I, which I can work out using the potential difference of the resistor. So I is equal to 4.5 divided by 12, okay, which is going to give me 0.375, okay, and times by R. So R ends up being 4 ohms. So B is the answer. Then question number 4. A student is given 2 identical filament lamps. Each lamp is labeled as 12 volts, 24 watts. The student connects the 2 lamps in series across a 12 volt supply of negligible internal resistance. Which of the following statements is or are correct when they're connected in series? So it says the first one as the resistance of each lamp is 6 ohms. Let's check, okay? So what we have is, if I just sketch a little diagram, so we have 2 bulbs, they both are identical, and this is 12 volts, okay? So I can work out the current first. I'm going to work out current as, and that would help me identify 2 as well, okay? Point number 2. So current is equal to power over voltage, okay? So that's just going to be 24 over 12, which is 2 amps. So 2 is therefore definitely correct, okay? And as for the resistance, now resistance, the total resistance we can find out by using the total voltage, which is 12 over 2 amps, okay, which is 6 ohms. So the total resistance is 6 ohms, okay, so therefore this is definitely not the answer, okay. The resistance of each bulb would be 3 ohms, okay. Now, so we are, that basically cancels out, eliminates. And then finally we have the potential difference across each lamp is 6 volts. Let's find out again. So they are reading 12 volts, yes, but it's not necessarily going to have 12 volts because they're connected in series, okay? So the voltage or the potential difference is going to be shared among both of them. So yes, number 3 is also correct. Okay, so B is the answer therefore. Okay, so question number 5. What is the de Broglie's wavelength in nanometers of a proton traveling at that much speed? Well, that's easy. Okay, just use this equation and get your answer just make sure you convert it into nanometers by dividing your answer by 10 to the power of minus 9. Okay, so you're going to have something like this. Okay, so you get 2.64 something something 10 to the power of minus 11. Okay, and when you divide it by minus 9, 10 to the minus 9, it ends up giving you A as the answer. Okay, question number 6. A wire X has length L, radius R. Another wire Y has been made from the same material, but the length is 2L, radius is 3R. The wires are connected in parallel. Okay, so what is the correct ratio? Okay, so parallel means V is constant. Okay, which means that I can use, I know that P is equal to V squared over R. And also therefore P is inversely proportional to R. Okay, so I know that much, and I also know that the resistance is proportional to the length. Okay, so I'm just going to call it L X. Okay, Rx. Okay, is proportional to L over R squared. Okay, and for the resistance in Y, that will be proportional to 2L over 3R whole squared, which is 9R squared. Okay, so I'm not worried about the constants. Okay, so if I was to now work out the power dissipated in Y, okay, which is basically power we know dissipated in Y is inversely proportional. Okay, and then I can just flip this around. I'm just going to write it down actually like this. Okay, inversely proportional, so it's easy this way. So that is going to give me L over R squared times by 9R squared over 2L, so 4.5. Okay, cool. I mean, I like to do ratios, but if you see it immediately, all good. Okay, I always like to show my working out, even though it might take me more than a minute. Okay, so I'd rather be safe than sorry. So let's move on to question number 7 now. So for question number 7, it says that a student records the following data during an experiment to determine the internal resistance of a battery. EMF is given to us along with potential difference and current, and it's asking us what is the percentage uncertainty in the value of this internal resistance of the battery. So for this particular question, you know, it's a very, very good question, because most of us would end up just working out the percentage uncertainty of EMF, potential difference, and current, and then add them up all. Okay, for which one of the answers is already provided. Okay, however, you have to be careful here. We know that potential difference and the EMF, they are both basically in volts. Okay, they both will account for, therefore, the error in internal resistance. So what we have to consider is working out the upper limit in the internal resistance due to the errors in the EMF. Okay, EMF which is 0.2. Okay, and the terminal potential difference as well, which is 0.1. Okay, so we would have to work out the upper limit, the lower limit, therefore we would have to then work out the half the range and then the percentage uncertainty. So I feel like this question is very, very unfair for just 1 mark, given how much work goes into it. Okay, like you have to do quite a few calculations in order to arrive to the correct answer at the correct answer. So let's get started. Okay, so first of all, I will work out the actual value of the internal resistance. So we know that EMF is equal to V plus IR. So R is equal to 4.5 minus 3 over 2, okay, which gives me 0.75 ohms. So that's the actual value of the resistance, which we're going to use at the end to work out the percentage uncertainty. Now, to work out the actual error due to the voltages, we have to consider the upper limit, okay, in the internal resistance. Okay, so what we have to do is we have to think a little bit about this one. So let's talk about the upper limit. So with respect to R, okay, the error in R, it would be, if you want the highest value, you want the denominator to be the lowest. Okay, so you have to therefore consider the lower limit of, I'm just going to call it L for lower, lower limit of the current, okay, and then you would want the big number, okay, at the top, so high minus low. Okay, that's just simple maths. Okay, if you want the a big value, then the denominator should be small and the numerator should be big. So the the upper limit in the EMF, okay, is going to be 4.5 plus 0.2. Okay, so that'll be 4.7. Then minus the lower limit in the terminal potential difference, which is 3 minus 0.1, so 2.9. So that over the lower limit in the current, which will be 1.9. And this one will give us 0.95 ohms. Okay, now that's just one part. Then we have to work out the lower limit. And yet again, in terms of maths, okay, we know that the lower limit, we would need a high value, okay, for the denominator. And we want to go for the smallest difference, okay? So we would have to consider the low in the EMF minus the high in the terminal potential difference. So this will then induce, the lower limit is 4.3 minus the upper limit is 3.1, okay, divided by the upper limit of current, which is 2.1. And that gives me a value of 0.57 ohms. So now we're almost there. Okay, so in terms of the error in R, okay, we would have to consider half the range. As always, this is a formula worth remembering. Okay, if you are given the range of values, you consider half the range, okay, to get the absolute uncertainty. Okay, absolute uncertainty. Okay, so absolute uncertainty therefore in R is half times by the difference in the two, and that would end up giving me a value of 0.19 ohms. Okay, and there I can finally work out the percentage uncertainty in R, okay, which is the value of 0.19 over the actual value of the resistance, which is 0.75, and times that by 100, which gives me 25.3, and so the closest answer is D. Okay, so I think this is one of the most horrible questions I've seen for multiple choice. This should be actually, in reality, a 3 marker at least. Okay, so but it is what it is. Let's move on to question number 8. Okay, so we're given that a capacitor consists of 2 parallel plates separated by air. The capacitor is connected across a DC supply. The charged capacitor is then disconnected and the separation between the plates is doubled. Which statement is correct about the charge stored by the capacitor? Well, the charge stored is not going to be affected anymore. If you disconnect the capacitor, the charge has already been stored. It is therefore going to be the same. It doesn't get affected by anything. Okay, so it's already there. Okay, charge stored. Okay, so question number 9. 4 capacitors of capacitances 10, 20, 30 and 40 are connected in series to a battery. Which capacitor has the largest potential difference across it? So we need to know the relationship between capacitance and the voltage. We know that capacitance is inversely proportional to the voltage, and therefore the largest PD will be for the smallest capacitor, therefore A is the answer. Okay, question number 10. The diagram below shows a transformer, and the primary coil is connected to a switch S and a cell, and the secondary coil is connected to a voltmeter and the switch is now closed. What is the correct statement? So one thing we need to keep in mind that a cell is a source of direct current. Okay, so once the current starts flowing, there's not going to be any difference. There's not going to be any change in the direction of the current. So C will be the answer, because when you close a switch, current will start to flow, and therefore there's going to be a reading. Okay, there's going to be an EMF induced. However, because the current is not changing direction, there's no change in the magnetic flux. Okay, therefore the the voltmeter reading will decrease to 0. So here we go, C as the answer. Question number 11. A charged particle traveling with speed v describes the circular path of radius r in a plane perpendicular to a uniform magnetic field. The orbital period of this particle is t. The same particle now travels with a speed of 2v in a circular path in the same plane as before. What is the orbital period of the particle now? So we have to therefore look at some relationship, whether there is one or not, between the velocity and the time period, because those are the two things in question. So what we know is the force experienced by a charged particle in a field is BQV, and that is equal to mv squared over r, as it is centripetal force, it's circular motion. So v cancels out with v, okay, as in one of the v's, and we know that b, q, and m are constants. So v is directly proportional to r, and there's no mention of t in this equation, as in we would have to, rearrange this to get it in the form of t, which we don't need, because we need a relationship between v and t. So that means that t does not get affected by v, and therefore C is the answer. It's a very good question, okay, because a lot of you will either go with the formula of 2 pi r over t, and you'll be like, oh, okay, if the v is doubled, then t is going to be halved. But no, it's not that straightforward. You have to think about in terms of forces. Okay, so C is the answer, and let's move right on. Question number 12. What is the correct decay of a quark? Okay, so seems like all of them represent some sort of versions of a beta negative decay, right? So because of the electron. Okay, so in a beta negative decay, we know that a neutron turns into a proton, and an anti-neutrino along with the beta particle is given off. Okay, so I'm just going to write it down over here. Okay, so it could be A or therefore D. Okay, so we have to figure out which one is actually correct in terms of quarks. So we know that neutron is made up of UDD quarks, okay, and protons are made up of UD quark. So D is turning into U, okay, and that is represented by the equation in D. Okay, so D is our option. Another way of looking at this question is you can look at the charges, okay, whether the charges are conserved, and you can do it like that as well. Now, question number 13 is rather easy. We have to figure out what is the correct unit of acoustic impedance. I can never say that right. Anyway, so Z is rho C, okay, and rho is density. So it is going to be, B, okay, so that's easy peasy. Question number 14. What is not a component used in a gamma camera? Well, that's just, you have to know your medical physics, okay? What we don't use is an X-ray tube in a gamma camera. Okay, so A is the answer. So worth remembering these things, guys. Question number 15, not 5. here we have a diagram which shows a beam of ultrasound incident at the boundary between two materials, and the Z value, or the acoustic impedance, is given of P to be 1.5 times that of Q. So ZP is 1.5 times ZQ, okay? What is the percentage uncertain, what is the percentage of the ultrasound intensity transmitted at the boundary? So we know the intensity reflection coefficient, which is IR over I naught, okay? And that's given to us as ZQ minus ZP, ZQ plus ZP, as this is the second medium, okay, and this is the first medium. So all that is squared, and once you put that into the form of 1.5 ZQ, ZQ plus 1.5 ZQ, they will cancel the ZQs out, okay, and you'll be left with minus 0.5 over 2.5 squared, okay, which gives you 4%, okay, and that's 4% reflected, so therefore transmitted will be 96%. So D is the answer. Okay, so that's question number 15 done. This is the end of section A, and I will be doing section B in the next video, so next week, okay, and section B is really good. I'll put a link in the description box below so you can go ahead and try this paper out yourself, and you can also compare the answers next week if you wish to. Thanks ever so much for watching this video. I'll see you guys next time.